Dear students, welcome to my channel Physics World. Today we shall study the second chapter of class 8, Physical Quantities and Measurement. We shall start with density. We have studied in class 7 about density, so this is a little bit of recapitulation. It has been observed that equal masses of different substances have different volumes. Now, there is one example given over here. So, let us consider this. This is the volume of say 500 gram of cotton is much greater than the 500 gram of iron. This is we have this experience of knowing this. Similarly, we also know and we have seen that equal volumes of different substances have different masses. So, if we have say 1 meter cube of cotton and 1 meter cube of iron, they will definitely have different masses. So, a new physical quantity, that is density, which may be represented by small letter d, is defined as mass per unit volume, where mass is written as capital M and volume is represented as capital V. Therefore, the formula becomes density d is equal to mass by volume. Density can also be sometimes represented by the symbol rho. This is how we write the symbol rho. I shall write it once again for you children. This is the symbol. So, instead of writing d, you may write the symbol rho. Density is a scalar quantity. Now, a little bit recapitulation for those who have forgotten what is a scalar quantity, or maybe for those who don't know what is scalar quantity. A scalar quantity is one which has only magnitude and no direction. That means only magnitude is required for describing a scalar quantity and direction is not required. For example, if you go to buy some grocery and you say that I want 1 kg of sugar. So, you don't say that I want 1 kg of sugar in the east direction or the west direction. You don't specify the direction because mass is a scalar quantity. Similarly, density is a scalar quantity as it has no direction. Now, we shall come to the unit of density. A unit of density is nothing, this is but the unit of mass divided by the unit of volume. Okay. So, now in the SI system, when we are talking about the SI system of density will be nothing but the SI unit of mass divided by the SI unit of volume. SI unit of mass is kilogram and the SI unit of volume is meter cube. Therefore, the SI unit of density is kilogram per meter cube. Now, we shall talk about the CGS unit of density. The CGS unit of density is nothing but the CGS unit of mass divided by CGS unit of volume. The CGS unit of mass is grams and the CGS unit of volume is centimeter cube. Therefore, the CGS unit of density is gram per centimeter cube. You must see in both previously also, here also, we represent gram per centimeter cube. Either you can write it this way, gram per centimeter cube, or you may write gram, omit the slash, minus 3 centimeter cube minus 3. This minus sign indicates that the centimeter cube is in the denominator. Using the exponents, right. So, now we are coming to the relationship between the SI unit and the CGS unit of density. So, let us see how the SI unit and the CGS unit of density are interrelated. So, 1 kilogram per meter cube is equal to 1 kilogram by 1 meter cube. Now, to change it into gram per centimeter cube, we shall expand and write that is equal to 1 kilogram divided by 1 meter cube is actually a cube. It is a space occupied by a cube and a cube has all the sides as same, right. They have the same side. So it is, if we are talking about 1 meter cube, now A is equal to 1 meter over here. That means we have to write 1 meter into 1 meter into 1 meter. So that becomes 1 meter cube. Now 1 kilogram per meter cube therefore is equal to 1000 gram divided by each meter has to be converted into centimeter. So 1 meter is converted into 100 centimeter over here. This 1 meter is also converted into 100 centimeter over here. This meter has also been converted into 100 centimeter over here. Cancel the zeros and we get 1 kilogram per meter cube is equal to 1 by 1000 gram per centimeter cube. So we get, if we just cross multiply, we get 1 gram per centimeter cube is equal to 1000 kilogram per meter cube. Now we can write it this way, that is 1 kilogram per meter cube is 1 by 1000 gram per centimeter cube, or 1 gram per centimeter cube is equal to 1000 kilogram per meter cube. Okay. So now there are certain frequently asked questions, we shall be discussing those. The density of mercury is 13.6 gram per centimeter cube. Explain the statement. This is very simple. Let us read it once again. The density of mercury is 13.6 gram per centimeter cube. This simply means that the mass of 1 centimeter cube of mercury, mass of 1 centimeter cube of mercury is 13.6 grams. Mass of 1 centimeter cube of mercury is 13.6 gram. Now this mass has been underlined over here. If you write weight, you go wrong, because you know now what is the difference between mass and weight. Definitely. So you just cannot use the term weighs 13.6 gram. Even if you say weighs 13.6 gram, you go wrong. So please use the right term while defining or explaining the statement. Dear students, coming to the second most frequently asked question, and that is, how does the density of a substance vary with the body's shape or size? Now dear students, the density of this substance is the characteristic property of that substance. It does not vary with the shape or size. I will give you one random example. Like if we take an iron, and we know that the density of iron is 7.8 gram per centimeter cube. Now if we take that iron and we hammer it and thereby change its shape or size, it will still, for 1 centimeter cube, it will have a mass of 7.8 gram. That means its density will not change, unless of course the temperature, it is being heated, and on heating of course there will be a volume expansion and then the density will change. Now we are coming to the next, that leads us to the second question of course. How does the density of a liquid vary with an increase in temperature or a variation of temperature? So let us ask this question in general with a variation of temperature. Explain. So first of all, I see children, over here you can see I have given a very detailed answer. Obviously it must be working behind your minds that, ma'am, do we need to give such a detailed answer? No children, this is for an explanation. You will give only that much portion which is required. Let us understand everything and then we shall come back to how much answer has to be given. Since this is a general question I have written, that with the variation of temperature we are explaining everything. Now this question may be modified into how it varies with an increase in temperature or a decrease in temperature. So let us see this question. So all substances we know that they expand on heating and contract on cooling. So the volume increases on heating and decreases on cooling. So we know the density is mass per unit volume. That means mass remaining constant. See, whenever we are saying that it is inversely proportional to volume, density becomes inversely proportional to volume. Something is constant over here. What is constant, children? Mass. So mass remaining constant. Mass constant. That has to be very clearly understood over here. So, mass is constant, and therefore, if the volume increases, density decreases. That means it is inversely proportional. For those who do not exactly understand the meaning of inversely proportional, let me just in one sentence or two I make you understand that if this inversely proportional means that if volume increases, the value of density will decrease, and vice versa. And not only that, it does not only mean that, it also means that the rate at which volume increases, mass remaining constant, that is the rate at which the density decreases, the value of the density decreases. So, they are inversely proportional. Okay. So, now thus the density is inversely proportional to the volume. Hence, on heating the volume increases and therefore, the density decreases. Up to here it has been understood. Now, we will come to water, which shows an exceptional behavior, or we say that as the anomalous behavior. It acts differently. Why it acts differently? Because of its anomalous behavior or the anomalous expansion. Now, what is that anomalous expansion? From 0 degree to 4 degrees Celsius, water when heated, it contracts. Therefore, the density increases and becomes maximum at 4 degrees Celsius. Okay. After 4 degrees Celsius, if the water is further heated, then now it expands like normally any other liquid would do. So, therefore, its density decreases on heating beyond 4 degrees Celsius. So, this is the entire answer, because the question was in general, vary with the variation of temperature. Now, if they ask you how does the density of a liquid vary with an increase in temperature. So, of course, you will have to say that the density decreases with the increase in temperature, mass remaining constant. Always explain anything you are explaining with the help of some law or some formula which you have learned. You have learned this formula, so explain it with the help of this. But if they ask you how does the density of water vary, then only talk about the anomalous expansion, right? Next, we come to the density of irregular solids. So, let us see that the density is nothing but mass per unit volume. So, our first step would be to measure the mass m of the given regular shaped solid. Now, for measuring the mass m, we can use a physical balance or an electronic balance. We will be preferring either physical balance or an electronic balance, because both of them are very sensitive. Now, a beam balance would also do, because it measures mass. Step 2, we have to determine the volume V using the appropriate formula. Because it is a regular solid, we can as well use the formulas which we already know. Volume of a cube is equal to side cube. What is the volume of a cube? Cube is a 3-dimensional solid whose each side are equal, all the sides are equal, and let that be A. So, in that case, side cube becomes equal to A cube. Volume of a cuboid. Now, cuboid is a 3-dimensional structure where length, breadth and height are all different, this kind of a 3-dimensional structure. So, length, breadth and height, if we take it as L, B and H, then we can write it as L into B into H. Volume of a sphere. Now, volume of a sphere is equal to 4 by 3 pi r cube, where r is the radius and pi is 22 by 7 or 3.14. Volume of a cylinder, if this is the cylinder, it is always the volume is the area of the base into height. The area of the base, which is a circle, that is pi r square, and height h multiplied by the height h. Okay. So, now comes the step 3. Knowing the mass m and also knowing the volume V, now we can calculate the density using the formula density is equal to mass per unit volume, or D is equal to m by V. Dear students, the first part ends over here. We shall meet soon with the second part. Till then, please do not forget to like, share and subscribe. Thank you.